Hi, this video is about the top 3 reasons why most AI strategies fail and how to avoid failure. My name is David Hood, and I'm CEO of 42 Robots AI, where we help organizations implement AI. Don't have your board or the other people at your company be like Bob Barker here, where they're kind of disgusted by the failure. You should know by now that just about every business process and just about every business in the world is going to be impacted by the modern LLM, large language model technology that's the latest in AI. I'll put some links that are relevant below in the video that will help expand on some of these concepts. So, number 1, bad solution architecture. I just keep seeing this over and over and over again, and it kind of blows my mind that this is still quite pervasive because based upon our research, based upon lots of data, this has been super obvious to us for over a year that this is not the way to go, yet people still talk about it like this. This is still what most people talk about it. When I talk to real nerds who are solving real world problems, they get it. They nod along when I explain this because they know they've seen it. And maybe they haven't quite articulated it in the way that I'm going to articulate it here, but this is absolutely critical. This is the crux of all the issues of why enterprise isn't getting value out of LLMs, why a lot of people don't really believe that LLMs can really add value. And there's a variety of reasons, a variety of things that are kind of all coming together to make a perfect storm here. Number 1, virtually all of the research, the money, the time, the energy, everything is going into where the model is the solution and the solution is the model. And you can see this when people talk about solving problems with LLMs. They'll kind of talk about, yeah, we train the model, the model this, the model that, the model this, the model that. When you hear that, you know they have not figured this out yet. They have not figured out that this dramatically reduces their ability to solve problems by focusing on the model, by being so LLM-centric, where a single LLM is put at the center, or maybe they have a few that are kind of connected together, and it's got this very kind of no-codey, high-level architecture where there's prompt engineering and maybe some RAG and maybe some tools. This is very limiting. This is the improper architecture for just about every solution out there, I promise you, and this is backed by lots of data, lots of research, lots of actually solving real-world problems. And the problem is that this is the more interesting and fun way to go about doing things. And so you have a bunch of academics who are trying to do what's fun and interesting. I've heard many times in a variety of different ways, basically like PhDs in computer science who are more respected in terms of how to use AI, yet they're focusing on what's interesting and fun and solving big problems that might take many years as opposed to actually being practical about it. All right, and I saw this one podcast where a PhD in computer science started to go down the more practical path. He just briefly, his brain went there and he started talking about it. And he goes, "No, that's not interesting. That's not fun. I want to play with these, for lack of a better, go summarize. I want to play with these magic boxes in the way that is interesting to me. And if I have to go about doing it, solving it that way, that's not very interesting." Well, I'm not in the business of necessarily what's interesting and fun. To me, it is interesting and fun to go about it solving in a practical way because it solves real world problems for real humans as opposed to lots of hand wavy and lots of things. That doesn't really satisfy me personally. So the right way to think about this is that LLMs are tools. They are not the solution themselves. They are tools to be used inside the solution. And it is software centric, just like a classic software architecture where you got an algorithm and you got a step, and at this step you want to use an LLM because you can't solve the problem any other way. Or a lot of times LLMs are really good at getting the edge cases that are really hard to hard code into software. This is going to open up all of the possibilities that are out there for LLMs, and there is a lot. And there's a lot of hand wavy, and that's where we get into number 2 and number 3 in terms of what you can actually do with these things. But as a result, what you do with the bad solution architecture, you've got this LLM at the center, and you try to shove as much of the solution in there as possible. And what this does is creates all sorts of problems. And there are some things where that works, but in general, the more of a solution you try to shove into an LLM, the more challenging it's going to get, and the more that as you shove more and more in there, the more what you maybe solved before is going to actually fail. With a software-centric solution, you're using the multiple LLMs at multiple steps to do specific things. You're actually pulling as much of the solution out of the LLM, and as a result, you get way more reliability. This is absolutely critical to actually solving real-world problems. That's part of the problem with the solution is the model. The model is a solution. You don't get, it's very unreliable. It's almost impossible to make this really reliable for specific use cases for organizations. This is also part of why GPT-7 or GPT-20 or whatever is not going to just solve all the use cases. And I'll explain a little bit more about that in a second. This is the practical way to go about doing it. And watch my my bad AI solution architecture and custom AI solutions videos for more details on that. There's a deeper there's multiple deeper concepts in terms of what to do right and why a lot of this is happening, and why a lot of the kind of bad architecture is happening. So the other mistake is lack of new capabilities that are understanding that come about from LLM. So LLMs in their modern form create new opportunities for things that we just couldn't do before. Now, most people view this as basically chatbots plus maybe some summarization type stuff. But there's a whole lot more that LLMs can do, and I didn't list even close to everything on here. I have a video just for this that I'll link to. And even that I don't think is an exhaustive list. I think we're still discovering some of the things that it can do. But one of the key things is turning the semantic meaning of words into math, which enables vector databases, a new type of database, and retrieval augmented generation, which is incredibly useful. This is a key kind of fundamental piece of how LLMs work, and so they kind of rise together, even though it actually ends up being useful separately from LLMs. Data processing. This is such a broad term. There's so many different, and this is where a lot of my personal history, I spent a lot of time processing large amounts of data with code. There's all sorts of different data processing possibilities, from data extraction to data analysis to data merging. There's a whole host of different cool stuff that you can do. And I think this has been majorly upgraded with LLMs. Our ability to process data has been leveled up by multiple orders of magnitude, 100x, maybe 1,000x, 10,000x, depending on the specific scenario, over what we could do before. And there's tons of data out there that is either under-leveraged or it's being expensively leveraged by manual labor. This is a key thing that I think is getting it's not getting completely ignored, but it's largely ignored. And to me, this is one of the most valuable parts of LLMs in businesses right now. And then triage within, especially if you're thinking about this software, if you're thinking about this like up here in the LLM centric, this doesn't really add a lot of value. But if you think about this in terms of you have a process that sometimes you need to go here, or here, being able to triage in a way that is more dynamic and more flexible and allows for handling edge cases that you don't necessarily have to specifically define is incredibly useful. Categorization, this is kind of fundamental to what the modern LLMs, when they first came out, I think it was AlexNet, I want to say it was 2011, 2012, so about 12, 13 years ago, it was basically just categorization. So this is something that they can do really well. So really hone in on and make simple, because this is not, at a high level, this is not that complicated. What can they really do that's new? And break it down into just really simple ideas. Data processing, data analysis, data compression, all that stuff. Very, very simple. And then use that as a guidepost to help you understand what is best for your organization. Lack of understanding of limitations of LLM. I think this is maybe not just lack of understanding, but also lack of being able to acknowledge it, lack of wanting to acknowledge it, lack of having an incentive to acknowledge it. So there's a couple things. So some people actually go too far, and they say LLMs are just imitation engines, which is actually technically correct, but effectively not correct, because they can do a lot more. Look at the new capabilities. They could do a lot more than just what you imagine an imitation engine can do. I think a really good way of looking at this is that makes this a little bit more clear is that they can create new recipes, but they can't create new ingredients. So a new recipe would be taking the same ingredients and combining them in a novel way, versus new ingredients would be discovering a new law of physics. I don't think that they're anywhere near doing something like that. Unless that new law of physics is an amalgam of old laws or old pieces of laws that they kind of recombine together. But one of the key things here is that the next token prediction is extremely limiting. It doesn't go backwards. There's randomness there. And so basically when it's trying to generate a response, it's doing a little chunk of text at a time. It's not reviewing and going back. And when it does the 10th one, it doesn't go, oh, does this make sense to where based upon when I'm going? No, it just does it doop, 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 one at a time, one at a time, one at a time. This is extremely limiting. There's a lot of benefit to LLMs for sure, but this creates a lot of problems, and this is why you get hallucinations. This is part of why you can't really have a self-managing AI system, especially on the old architecture. With the proper architecture, there's some possibility for that, but with the old architecture, it just inevitably goes off the rails because eventually it's going to pick a token or a set of tokens that goes in the wrong direction, and then it's just going to keep going further in the wrong direction. Really, when you look at what has happened and the trends for LLMs, they have plateaued. And anybody who says, no, it's still growing rapidly, the LLM technology is still like, boom, it's still going really fast, and there's no evidence to back that up. In fact, quite a bit of evidence to the contrary, which I'm going to present here. So when Google first presented their transformer paper in 2017, the code for that technology has not changed very much. It's almost the same 500 lines of Python code since 2017. I really think about that. Now, the data has changed and there are some tweaks to it, but in general, the foundational piece of that technology has not changed. Also, if you look at when GPT-4 came out in April 2023, about a year and a half ago, the LLMs have not significantly changed since then. They have not improved dramatically. Like you take GPT-4 from then and you compare it to Claude 3.5, which today is the best one, not on all the things, but broadly speaking. And it's not like Claude is 10 times better. Claude is a little bit better. It's, maybe 20 to 50% better. It's hard to give an exact number, but it's better, but not like, whoa, this is completely different. They have hit a plateau, and this is part of their limitations. They need more with each incremental linear step of improvement. They need orders of magnitudes more compute, therefore more expense and more data. And so this is going to, with the current architecture, the current structure of the technology, I would not expect large language models to, like GPT-5, to be like this completely new thing that is just like blows GPT-4 out of the water and it's 1,000 times more intelligent. I expect it to be more intelligent for sure, but the idea that it's going to be a whole new order of magnitude or better, again, is not really backed up by the data. So, how do you avoid failure? Do good architecture, and then have a foundational understanding of new capabilities and maybe being able to spell capabilities, and then ignore the hand waving and invest in interest and the hype for what LLMs can really do, which is another way of saying understand the limitations, understand what you're working with. I know that they have plateaued, but there's still a ton of value there that has been very untapped. And if you want help tapping that value in your organization, because the chances are very, very good that if your organization of any significant size, and I'm talking like 100 people or more, maybe even 50 people, that you have opportunities to compete better with your competitors with AI, give us a call or click the link below and get a free custom AI implementation roadmap for your organization. And I appreciate you watching. Give me a thumbs up if you like this video. Leave a comment if you have any questions or thoughts. Appreciate you. Have a great day. Bye.